All right, here we have lesson 9.2, equations and tables. Now we're not talking a kitchen table that you eat your breakfast at, but a different table, and you'll see what that looks like in a second. Your objective, I can translate or switch between tables and equations. So, if you've ever seen anything like this, you know they use them kind of in lower grades, but this is an input-output machine. If you start with the number x, and the rule is, inside of the machine, y equals x plus 3. So you would take whatever x went in, add 3, and your output would be y. Okay? So for example, if x equals 4, that goes in, follows the rule, y will equal x, which was 4, plus 3, which is 7. And it would output y equals 7. Now that's an input-output table, or machine. We're going to put that into a table now. So here's our input. If we have x as our input, the rule is you take whatever x was, you multiply it by 2, and add 1. And that gives you your output of y. So if we had 4 as our input, as x, we would do 2 times 4 plus 1. 2 times 4 is 8, plus 1 is 9. So let's show you another one. So 7 is our input. 7 is what our x is. So 7 times 2, let's do 2 times 7, because 7 is x, plus 1. 2 times 7 is 14, plus 1 is 15. That's our output. Here we have 8. 2 times 8 plus 1. And again, I just keep referring back to this rule up here. 2 times x, and x is our numbers in this column. 2 times 8 is 16, plus 1 is 17. And the last one, 2 times x, which is 10, plus 1. So 2 times 10 is 20, plus 1 is 21. And that's as simple as an input-output table is. And what our objective was is I can translate between an equation and a table. So here you were given an equation right here. That's an equation, right? Kind of looks like an expression because of the way it doesn't have our equal sign. But it is a rule, and we can put it into a table, and that's all the objective is for today. So if you can do that, then you're set. Make sure you can. Here's your input, x. Your rule is take x, subtract 6, and there's your output of y. Here's your first one, 12. So you'll want to do, I won't tell you. How about you pause the video and you fill in the table. Let's see if you can do this on your own. Okay. To correct your work, you should have done x, which is 12, minus 6, and 12 minus 6 is 6. So that's our y. This one, 17 minus 6, you should have subtracted that and gotten y equals 11. And 23, subtract 6, you should have had 17. So if you have those answers correct, you are already doing so well at this objective. And we only have a few more slides left. So if you did not understand this, please pause, let me help you, raise your hand, and I'll come help you. Okay, sometimes our tables are facing up and down, sometimes they are facing left to right, sometimes they go up and down. Just depends on the day, okay? Doesn't really change it though. So you're going to write an equation to show the relationship between the input and output. So what they've given you is a table with the numbers, and they say, what's the rule here? They didn't tell you the rule. You have to come up with the rule. You have to come up with your own equation. So y equals, and then you write in your rule here, and that's your equation. So let's take a look at what's the pattern. If 8 is our x, and our y is 16, well, to me, I automatically see they're either adding 8, they're doing x plus 8, or they're doing 2 times x. So let's check with the next one. So now we have 9 and 18. So if x plus 8, if that's our first rule, 9 plus 8 is not 18. So this rule does not work. Does 2 times 9 equal 18? Yes. It does. So far this rule is working. Let's double check with the other one we have. 11 and 22. If we have 11 times 2, does that equal 22? Yes, so this is our rule. Y equals 2x, or 2 times x. So to finish the table, if we had 10, we would do 2 times 10 equals 20. So here is our equation that they asked us to write. Y equals 2x. And we figured that out based on saying, well, what's the difference between x and y? What could our rule be? We came up with two possibilities. Sorry, let me get my laser out here. So we were looking at 8 and 16. We said, well, it could be adding 8, or it could be multiplying by 2. We wrote both rules out, and then we checked it with the next one. 9 and 18. X plus 8 didn't work anymore, but 2 times x did. And then we came to 11 and 22, and 2 times x worked for that one as well. So that's how we figured out what the rule was to fit our table. So I believe, yeah, here's a chance for you to try it. Write an equation, which is going to come right down here, to show the relationship or the rule between the input and output. And then make sure you finish the table. You want to figure out what number goes here. So here's your x's. Here's your y's. See if you can figure out what the rule might be. Okay, so I'm going to first look at my first column. I have 10 and 14. Well, one thing is, why is 4 more than 10? So it looks like if I had x plus 4, that would work. Is there any other patterns that I see there? It doesn't look like they're doubling anything. It doesn't look like they're dividing by anything. So let's see if x plus 4 works for the next one. 11 and 15. If x was 11, 11 plus 4, well, that works. Let's check this last one over here. 13 and 17. 13 is x plus 4 is 17. I think that is our rule. So y equals x plus 4. So let's fill out our table. If we were given x is 12, 12 plus 4 equals y, which would be 16. Okay? So that's how you figure out the relationship between your input and output, and you make a rule or you write an equation. Hopefully you got that right. If not, please raise your hand, ask me questions. You know I love answering questions. Here's your last one to try. This one's a little bit trickier, so it's kind of a bonus, but I still want you to do it. Okay? Here's your x's. Oops, I don't really want to do that, sorry. Here's your x's, 5, 8, and 10. Here's your y's, 17, 26, and 32. See if you can figure out the rule for each of these. It is the same rule, I just kind of gave you extra space to write it. Okay, there's a couple of ways we could look at this. Let's first of all talk about adding. 5 plus what number equals 17? It looks like 5 plus 12. Oops, sorry, let me get my pen out. So this is a possibility. Oh, that's supposed to say 12. Does that work? If 5 is x, x plus 12. Is 8 plus 12 26? No. Is 10 plus 12 32? No, this is not our rule. We tried, doesn't work. Are they multiplying by anything? 5 times 2? 5 times 3? 5 times 4? No, none of those work for 17. So we know it's not just straight multiplication. Any division? No, that wouldn't work. But take a look here. 5 times 3 is close to 17. So let's do 3x. If I have 3x, because 8 times 3 is 24, which is close to 26, and 10 times 3 is close to 30. I think that's a good place to start. So if I had 3x for each of these, then I would have 5 times 3 is 15. What's the difference between 15 and 17? Well, they're adding 2. Okay. Now I have 8 times 3 is 24. What's the difference between 24 and 26? They added 2. 10 times 3 is 30. What's the difference between 30 and 32? Adding 2. So that is your rule for this problem. So again, it's kind of tricky. Sometimes it's not as simple as adding, subtracting, or multiplying or dividing, but sometimes there's two steps. We had to first multiply it and then add to it, okay? All right, that's the whole lesson for today. I hope that you understand it. If not, please raise your hand and ask me. You will have plenty of practice with all of your appetizers and your homework pages. So, thank you for listening. Have a good day.